Welcome to Lasea class. I am your teacher, Jan Lasea.
A blessed day to everyone! Today, we are going to learn about Discomfort Index or Temperature Humidity Index using Arduino Uno microcontroller, DHT22 module, and OLED display. A discomfort index measures how much discomfort a person feels with a given air temperature and relative humidity. The higher the relative humidity and the air temperature, the greater the discomfort index. Conversely, the lower the temperature and humidity, the lower the discomfort. The temperature humidity index is a combination of temperature and humidity that is a measure of the degree of discomfort experienced by an individual in warm weather. It was originally called the Discomfort Index. This is the formula to calculate the discomfort index. Di is equal to the constant 0.81 to be multiplied by T temperature to be added to RH or relative humidity multiplied by the constant 0.01 to be multiplied to the quantity constant 0.99 multiplied to the temperature T to be subtracted to 14.3, and then finally it will be added to the constant 46.3, where Di stands for discomfort index, T stands for temperature in degrees Celsius, RH stands for relative humidity in percent. To interpret the meaning of the computed discomfort index, we use the decision table below. If the calculated discomfort index is less than 55, our body will feel cold. If it is within the range 55 to 60, we feel chilly. If it is within the range 60 to 65, it is nothing. If it is within the range 65 to 70, it is pleasant. If it is within the range from 70 to 75, it is not hot. If it is within the range 75 to 80, it is slightly hot or somewhat hot. If it is within the range 80 to 85, it is sweaty hot. If it is greater than or equal to 85, it is too hot or sweltering. The materials we need to build a simple project are DHT22 temperature and humidity sensor module. The DHT22 is a basic low-cost digital temperature and humidity sensor. It uses a capacitive humidity sensor and a thermistor to measure the surrounding air and spits out a digital signal on the data pin. You can purchase the materials at the Layad Circuits Electronics Engineering Supplies and Services, Room B314, Lopez Building, Session Road, Baguio City, Philippines. Or you can visit their Facebook, written in this slide. Next, the OLED I2C 128 by 64 display. The OLED or organic light emitting diode can display anything from text to images with its 128 by 64 OLED pixels with monochrome color depth. It works with 3.3 volts to up to 5 volts power supply. The diagonal size of this OLED is 0.96 inch. OLED is a technology that uses light-emitting diodes in which the light is produced by organic molecules. Next, we need to use the Arduino Uno R3 microcontroller. Next, we need to use also a breadboard. We need also to use jumper wires and USB cable for Arduino Uno. We need also to use the Arduino CC++ IDE. The version 2.2.1 for Windows 11 is what I use. But you can also use the old version 1.8 for Windows 7. We need to download the following libraries such as the Adafruit GFX, Adafruit SSD 1306, and DHT Sensor Library. You must connect your computer to the internet to download these libraries from the Arduino IDE. On the Arduino IDE, click the Library Manager button at the left panel and then type the Adafruit GFX to search and then click Install. Next, we need also a laptop or a desktop PC. This is the wiring diagram for our simple project. To connect the OLED display to the Arduino Uno R3, from the OLED display, the ground pin will be connected to the ground of the Arduino Uno. The VCC pin of the OLED display will be connected to 5 volts. The SCK or the system clock of the OLED display will be connected to the analog pin A5. Finally, the SDA or the system data of the OLED will be connected to the analog pin number A4. Next, to connect the DHT22 module to the Arduino Uno R3, the ground pin of the DHT22 will be connected to this ground pin of the Arduino Uno. The VCC pin of the DHT22 will be connected to the 5 volts pin of the Arduino Uno. And then finally, the data pin of the DHT22 module will be connected to the digital pin number 7 of the Arduino Uno microcontroller. And then finally, we use the USB cable to connect the Arduino Uno microcontroller to our computer so that we can be able to upload our sketch or programming codes to the Arduino Uno microcontroller. Let us look at the program codes to be uploaded to the Arduino Uno microcontroller to know the temperature, humidity, discomfort index, and its interpretation. In our code, we include a lot of header files from the 3 libraries we just installed, such as SPI, wire, Adafruit _GFX, Adafruit _SSD 1306, DHT, DHT_U. Next, we read some defined directives such as the screen width of the OLED is 128 in pixels. The screen height is 64. The screen address assigned by default is the hexadecimal 0x3c. The default I2C address of the OLED display is 0x3c. You can change this if it is different. Note, if the OLED I2C address 0x3c does not work for you, then you can upload the sketch find _I2C address that I provided and read the output from the serial display of the Arduino IDE to learn the I2C address of your OLED display. Next, we instantiate the class Adafruit _SSD 1306 and declared an object named display. and pass some arguments such as the screen width, screen height, the variable wire, and then the OLED reset. The assigned data pin for the DHT22 module is digital pin number 7. And you can change to a different digital pin number. Next, we instantiated the class DHT and declared an object named DHT and passed some arguments such as the DHT pin and then the DHT type. Finally, we declare some global variables to store information such as the following: float, temperature, humidity, DI, an array of characters, name message, an array of characters, name buffer. The method or function setup is run once by the microcontroller. We call the function begin of the object DHT to start measuring the temperature and humidity. The command display that clear display will clear the memory buffer. The command display that set text size will set the size of the text. The command display that set text color will assign a color that it will be used to display the text. The command display that set cursor will position the text where it will display to the location specified in X and Y coordinates. The command display that println will display the text to the memory buffer, but it will not yet display to the OLED display. The command display will display the memory buffer to the OLED output device quickly. This is a double buffering technique to reduce screen flickering. This will display the profile of the software developer. Finally, it will pause for 5 seconds, and that is enough to read the contents of the OLED display. The function loop is called repeatedly by the microcontroller. It will first pause for 2 seconds, and after it will read the measured temperature and humidity from the DHT22 module. The command DTOSTRF will convert a float value into an array of characters or string. Both the temperature and humidity will be displayed or stored to the memory buffer using the command display.println. This is the continuation of the code of the function loop. The code will calculate the discomfort index and store the value to the variable di. The function DTOSTRF will convert a float value into an array of characters or string. The computed discomfort index will be displayed or stored to the memory buffer using the command display.println. This is the continuation of the code of the function loop. The code will interpret the meaning of the computed discomfort index using the if-else statements. If it is cold, chilly, nothing, pleasant, not hot, slightly hot, sweaty hot, and too hot. The command display.println will display the discomfort index interpretation to the memory buffer. Finally, the command display.display will display the memory buffer to the OLED output device quickly. And now, we can now read the displayed information. Ladies and gentlemen, let us run and test. As we can see in the OLED display, it displays the current temperature in my room, which is 26 degrees Celsius. The humidity is 79%. The computed discomfort index is 77. And then the interpretation of that discomfort index, your body feels slightly hot.
That ends our topic for today. I hope you are inspired in my class. Thank you for watching. God bless us.